Thank you. Welcome to Context is Key, the context.Context object that everyone's passing around. Again, I'm Samuel Davidson. There's a Twitter handle for me and my LinkedIn if you're interested. I'll try and go fast here since we're a little over time. This talk is 3 parts. First is the design of the context object. Second is the API of the context object, of the context package. And third are a handful of useful usage patterns, certainly not an exhaustive list, but maybe some things you might recognize in your own code bases. And then a little Q&A hopefully at the end or in the breakout session. So the design of the context object. Just to clarify, we're talking about just the core context object imported as the string context. It's a core Golang package. You probably have seen it as a variable abbreviated CTX. That's where it comes from in the name of the talk. Instantiated context.background, or is the first parameter in some function. It's a super common package in Go, gRPC, Kubernetes, etcd, Terraform. It's all used as like a meaningful percentage of their files import the context object and use it in various places. Super common. It's particularly common in sort of front-end APIs where you're making RPCs. HTTP and gRPC sort of, you can bake a context into a request, send it off. Database SQL requires a context in like every other function. But if you're like me, at least up until making this talk like a month ago, I would be hacking away, providing immense value to my employer, of course, and I'd come across some function that took context as the first object, and I'd be like, okay, I still don't know what this is, but you know, the surrounding parent function has a context variable. I'll just kind of copy paste it in. It seems to work. Whatever. I don't get any errors. The program still runs fine. Okay, and that's kind of how that's kind of how we were always working, or how I was always working with context. Or worst case, I'd call context.background to just make a new one and hope that everything's fine, and that would also kind of work most of the time. But what is this mysterious black box represented as this little cube? So context is used for Go routines and RPCs. Since Golang is a very RPC Go routine heavy thing, it's like a core package. It's a state container, super simple state container of 3 things. The first is the cancellation status, which is a Boolean, a timeout, which is just a UTC of when this context cancels itself or expires, and then a bunch of key value pairs. So looking at a super quick example, this pretend context is not canceled. It's timing out in 30 seconds from now, and it's got some key value pairs in it. Maybe a request ID is a string and a UUID is another string, or credentials, which could point to some byte, PEM-encoded byte blob, which is like a certificate for me, Sam, hypothetically, with my credentials. And then the last thing about a context object is the creator of a context object can get this sort of cancellation function that we'll talk more about later, but basically they can call that function as in press in this TNT plunger, and it will immediately mark that context as canceled regardless of the timeout. And we'll go into that in a few slides. So let's look at a quick toy example of how and why contexts are passed around. We've got my computer here, my laptop, Sam's PC. I come over to it and I say, hey, my app, which is a pretend app, I'm going to query the database, right? And so on my PC, before it sends this query over the wire to the full network stack, it first creates a context object, maybe puts in a 30-second timeout and some local credentials to validate who I am, and then ships that request along with the context object onto the wire. And let's say it goes to a load balancer. The load balancer forwards that request and the context to a front end, which the front end could maybe just forward the context to an auth server, which could extract out those credentials, validate that I'm Sam and I have permission or whatever. And then it can keep going to the back end and the database and yada, yada. And the importance of the context object being copied all over the place here is all of these RPCs, all of these computers and VMs sort of asynchronously working through this request know that they're actually working through a single request. This is all related to Sam's MyApp query database. And it's timing out in 30 seconds. And that's useful for a lot of reasons, one of which is, let's say an error occurs in the back end. There are a lot of logging libraries that can take a context, or you can write your own that will sort of print that state and be like, okay, this request by Sam is erroring out, even though it's deep down the network stack. So let's dig into the first thing within context, which is timeouts. So again, this pretend context object is given a 30-second timeout. You could also set sub timeouts for any of these sort of copies of the context object down this network tree. So the front end could set a shorter 5-second timeout for the auth server. If 5 seconds expires, that request is canceled, or the context is canceled, and could retry a few times, whatever, right? Alternatively, the load balancer could set a shorter timeout to the request going down to the front end. And if 10 seconds were to pass, that context would be marked as canceled. All of those sub requests created by the front end would also be marked as canceled, basically saying we don't care about the response anymore. You can stop doing work, free up resources. And the load balancer, let's say it has a whole bunch of front ends. It could maybe retry on another front end. Maybe that one's having issues, some sort of outage. We could try again with again in order a shorter timeout. And then if another 20 seconds expires, then the root context with that 30-second timeout will finally time out, and everything down the tree will be canceled. And SAM's PC will essentially say, like, I don't care about this response anymore. All of you can stop working. This entire context tree is canceled. Hopefully that makes some sense. So with key value pairs, similar to context objects, I've got some SAM certificate baked into the original context created at SAM's PC, and that key and value is copied down the tree. All of these computers have access, all of these RPCs have access to that same key value pair. And you can do other clever things, like you can create a trace key value pair where trace is the key and the names of the VMs or computers or RPCs or whatever can be the value. And each of these legs of the journey could maybe append their own name to this trace value. This is actually how a lot of tracing libraries work, is they build off the context object just using key value pairs. I think that's how it's done at Google, at least in some stuff. It's pretty cool. And the value of this, obviously, there's a lot of value to tracing, one of which is, let's say a database error occurs. We have that context object. We can print that, like, oh, this error occurred in database foo from this backend and this front end, load balancer Seattle originating from SAM's PC, yada, yada, right? Pretty cool. Just one of the values. Another thing is just similar to how we can set a shorter timeout from the front end to the auth server. We can also append new key value pairs that are just for that context, that sub request. So the front end could attach its credentials and the auth server could say, okay, I trust this front end talking to me because it presented the front end's machine credentials. Similarly, maybe we lock down the database for security reasons, only backends, valid backends can talk to it, and they can sort of attach their own credentials to their own special keys or overwrite certain keys, whatever. So key value pairs are super useful for most sort of simple things like this, request IDs, timestamps, versions, etc. And you might be thinking to yourself, wow, these key value pairs seem very flexible. They are literally interface to interface. What if I put my request parameter in there, right? You could use it as a big giant box where you just put the username of the whoever and a query ID and throw an image in there. Why not? You know, start throwing tons of things in there. You really shouldn't do this. You shouldn't use the context object as an arbitrary key value store. This is a slide that the context devs really wanted me to emphasize because a lot of people get this wrong. Use context values for only request scoped data that transits processes and API boundaries. So it shouldn't be data that's relevant to only one little sub request, almost like a parameter. It should be sort of global state, like a trace or some auth credentials, stuff like that. That is more just sort of metadata almost. Why? Well, first of all, it's messy. You lose your type safety. You're just keeping a giant blob of untyped data. You're constantly recasting. You don't actually have visibility into the keys and values. You can't list them out. You have to just look them up one by one. And most importantly, the docs say don't do it. So don't do it. Anyways, last thing, I said we'd go into the cancel function. The cancel function is just a sort of magic function you can call to mark a context as canceled. When you create a context, often you get a cancel function back on that creation, and you can call it cancel, like I said 5 times. So SAM's PC, I could come along and say, you know what, never mind, I didn't mean to make this request. Hey, Control C, sig term, whatever. And my app could pick up on that and before terminating, call the cancel function, which would mark this context as canceled, but also automatically over the wire propagate that cancellation to any outstanding sub requests. Maybe it's in the middle of an auth validation, whatever. And that's valuable because all of these sub computers know that they basically stop doing work. Like they can free up resources, stop doing work, stop wasting their time with this, because I don't care what the response is anymore. I've canceled this. You could also do something like, well, maybe the load balancer wants to return really snappy, so it sends multiple requests to multiple parallel front ends and holds onto a cancel function for each. And then, holds onto a cancel function for each, and maybe one front end returns faster than the other, cancel the one that didn't return because we don't care about its response, and that cancellation will propagate down the wire. So naturally, sort of as contexts form a tree, because sub requests form a tree, essentially, right? Where you've got client PC or maybe SAM's PC at the root, and then that sends requests to a load balancer and multiple front ends and multiple auth servers. Sorry. Multiple auth servers and backends, databases. And as with this tree structure, has some interesting properties that's important to know about context objects. It's that 30-second timeout set at the root will propagate through the whole tree. All of these contexts have a 30-second timeout, but a 10-second timeout set at some sub node will only propagate that 10-second timeout to sub requests made from that timeout. So if 10 seconds pass, only these contexts will expire, while the rest of the tree will remain unexpired with 20 seconds left or whatever. Similarly, you can get a cancel function for some sub node, sub context object, and if you cancel that, only itself and its children down the tree will be canceled. And this is important because there might be a situation where maybe some sub RPC realizes it needs more time and wants to like back propagate the timeout forward and like tell the root to like please extend the timeout for the whole tree or something. You can't really do that. We can't do that at all. Similarly, context can't like arbitrarily just talk over to like neighbor, sibling contexts, nephew contexts or whatever and say, you're canceled. We don't care about your request anymore because I got this. Again, you can't do that. It's all up to like the parents and the sort of unidirectional tree structure to affect children and make changes. So design-wise, that is the entire design of the context object. It's for propagating cancellation, timeouts, and key values to downstream RPCs. Moving on to the API. So the API of the context package. This is where we get into how to actually use it. It's very simple. So a context object, that CTX object that you're passed, it is an interface. You can call done on it, which will return, it will either hang because the context is not done, so it'll just spin if you're pulling from that channel, or it will immediately return because the channel was closed. So if the channel is closed, the context is done. The error will return one of three things, either nil if the context is not done, or if the context is done or canceled. There are two types of cancellations. One is canceled, so it'll return context.canceled if the cancel function was called, or context.deadline exceeded if the timeout caused the context to be canceled. The third function is deadline, which will, if there is a deadline, and contexts don't necessarily need a deadline, they could have no deadline. If there is one, it will return true and that time. If there isn't, false and nil. And lastly, there's a value lookup where you pass it a key of any type and it'll give you either some value that you have to cast to whatever type you want, or nil if the value wasn't found. That's it. Only 4 functions, and they have relatively consistent returns, so relatively easy to understand, but leaves you with the questions of, I told you could cancel these contexts, or I told you can modify the deadline. How do you do that? How do you add values, right? And that will all become clear very soon. So what's important to understand about a context object is that contexts are actually 100% immutable. That context object you're passed, you cannot modify it in any way. It's basically read-only. You're listening to see if you're canceled. You're checking what your timeout is. Any new context object is actually an extension wrapping a different context object, wrapping its parent. If you think about a bunch of like maybe nested presents where you have like one context object is a small box, and then you wrap it with a new value into a bigger box, and then you wrap it with a new timeout in an even bigger box. That's an analogy I like. So as sort of to build off that, we've got our context object with that same 30-second timeout and that key value credentials and my identity certificate. Think of that as like a little present. And if we want to make a new context object or make some change, you have to basically wrap it up with the change we want. So like this 5-second timeout, let's say we're shortening the timeout for some sub context. We bundle it with 5 seconds and we put it in a new context object, a little bit bigger box, which externally will just look like it inherited that context, that credentials, and then have a new timeout of 5 seconds. But under the hood, there's a reference to the parent, and that's where it finds the credentials, but the 5-second timeout was overwritten by the parent. Similarly, we could do the same thing with request IDs. We could just add new values where request ID is sort of in the outermost box, and then if you reference into the parent, you'd see the sub IDs and the sub timeout. And we could extend this further where we take this context object and we bundle it up with a new key value pair. Let's say we overwrite credentials. So we have a new key and value of creds and robot. Then we get an even bigger box, hypothetically, in this analogy, that shows 30-second timeout, the new credentials, and that request ID. And again, under the hood, this is still just a bunch, like an object and a reference to a parent, an object and a reference to a parent, and so on. Just a bunch of nested boxes. So that also forces that tree behavior because the root is the smallest box and everything builds off its parent and encapsulates its parent and sort of has a pointer back. So you can't really reorder the tree in any way. It's very unidirectional. Now it's built out. But you sort of have all these nested boxes getting bigger and bigger, hypothetically. So any context object you see with tons of key value pairs in it is actually a bunch of different context objects bundled up. Anyway, so let's look at that API one more time. You've got the context interface that I showed you, as well as those 2 errors. I said that the error function will return. And then we've got 4 functions in package context, package level functions with cancel, with deadline, with timeout, and with value. These are how we make contexts or modify contexts. And it has all of these concepts I just talked to you about. They all take a parent as their first parameter. They all return a new context. The middle 2 are for modifying timeouts. The bottom one is how you add keys and values. The top 3 return a cancel function that you can optionally call to cancel, to immediately mark that new output context as canceled. And so if you're making a sub request and you want a cancel function, you just call with cancel. If you want time constraints, you call with deadline or with timeout. And if you want to attach some key value pair, you call with value. Pretty straightforward. And it builds up. You build up. It's okay to call these functions in series a whole bunch of times to build up whatever set of key value pairs you want. So the last part of the API that's important is background and to do. There's a chicken and egg of these 4 functions, which is what if you don't have a parent object? You're not allowed to pass it nil. So what if you don't have a context to pass it? The origin of all context, of all life in the context world is the background and to-do function. So if we look at that API one last time, there are 2 more package level functions, background and to-do, which each just return a context. They return a non-nil empty context that is never canceled, has no values, and has no deadline. So it has no timeout. It's never going to expire. It's never going to be canceled 100%. There's no API way to ever mark these as canceled. They're just reliably uncanceled parents with nothing in them. And this is the 100% complete package. This is everything there is to know about the core Golang package. These are all the functions, all of the features, all the API. And real quick, I want to touch on when you would use background versus to-do. Since they both seem to return an empty blank context. Background is used by the main function, initialization and tests, and is the top level context for incoming requests. To do is used when it's unclear which context to use or does not yet available. So basically, background is used anytime you need a parent, generally, but sometimes you'll instead use to do if it's unclear, if you have multiple contexts you want to pass in, or if like you were supposed to be passed a context, but like the API needs to be refactored to support context or something, and it's coming soon, so you put to do, and it just signals to developers reading your code that this is subject to change. Functionally, they're basically the same though. Functionally, at runtime, they are literally the same, except for one tiny thing I want to highlight that's kind of funny is if you go into context.Go and you read into background and to-do, you can see that they're both empty contexts on the left. They don't do anything special, but they print slightly differently. So if you want to print context.background as a string, then you use background. If you want to print context.to-do, you use to-do. But functionally, they operate exactly the same. Okay, last section. I'm going to run through a very non-exhaustive list of usage patterns, just some things I thought you should know if you didn't already. There's a million billion ways to use context objects, and this certainly doesn't cover all of them, but I thought these would be interesting. So the number one thing that I want to show you is always defer a return cancel function. So when you call context with timeout, you get a cancel function as the second output, and you might be tempted to just ignore it. But what you should always do is actually call defer cancel. Why? Well, what if typically when you make a new context, you're making a bunch of sub requests, and what if this request returns early while a sub RPC is pending? So deferring cancel means like if we error out early, then at least we will call cancel and let all of our sub requests know that we actually, we returned early. Oops, you can stop working, free up your resources. It's just kind of good code health. Similarly, you could have some request and just immediately spin off a sub request using the same context, but it wouldn't be such a bad idea to call context with cancel, assign it to a new sub context, a new context that's only used for the sub request, and then you can defer cancel there. Again, just a way to kind of keep your code healthy. If the sub request isn't relevant after this function returns, it's good to cancel and clean up resources if we're exiting early. I want to show you how to get deadline. So like I said, if it returns the deadline and then a Boolean if the deadline existed. So, assign the deadline to T and OK for the Boolean. If OK, then we have T assigned. We can do some simple math. We can do whatever we want with this deadline. In this toy example, I just print that this context times out in X milliseconds or whatever. A common pattern I've seen that I think is kind of interesting is a lot of times you will want to shorten a deadline for sub requests. So you're going to make a bunch of sub requests, but you want to shorten the deadline so that you have a little padding at the end. So you would get the deadline in the same way, but this time you do math to basically, let's say we want 200 milliseconds at the end. So we subtract 200 milliseconds from our deadline and create a new context with this shorter deadline, and of course defer the cancel because that's good clean code, and then we can make our sub requests. And the value of this obviously is if sub request times out for whatever reason, we know that we'll at least have 200 milliseconds to do some cleanup work or finalize or default to some other value, yada yada. Talking about values, setting and getting, you can set by using the context builder context.with value. I use the key request ID and create some UUID, whatever. And this is I reassign context to this new context that has this key value pair. We could be using that. We could pass that around to sub requests. We can assign our other things can care about this request ID later on. We can retrieve it with context.value using an identical key, and I cast it back to a string, and then that ID will contain our UUID string. And we can do whatever we want with it. In this case, I just print it because it's a toy example. One gross thing about this is we've got this duplicate magic string. This is a magic key that needs to be exact, and I copy paste this string around. So a common thing to do is just with your context keys, usually context is key, but with your context keys, you will assign them to consts, maybe at the package level. So we can reuse ID key and in both of these spots to set and get the value. So we move it to a common const and it's reused. I want to go through a really kind of interesting toy authorization lookup example. This is not so different than a real auth lookup that might exist somewhere in some go auth function. So let's say we're authorizing a request and we want to default the allowed to fail false. So we default it to false, and then we're going to validate the credentials and see if we allow it true. So first thing we'll do is we'll extract out the value creds. If creds is not nil, as if there's some sort of data there, then we can call some helper called parse auth from interface. Again, this is a toy example. These helpers don't really exist. If that succeeds, then we can do some allow list checking or something on that credential. And if all of that succeeds, then we set allowed to true. And then maybe at the end, if allowed was set to false, then we return a 403. This is sort of a toy authorization lookup. And what we can do is we can combine the concepts from this with the last slide to basically build out our own common package that uses the context libraries. This is a very common pattern for how you want to build functionality extensions to context objects by using keys and values. So we're going to make a new silly package called auth library. We're going to make a type, just a type that aliases string, just to give type uniqueness to our key. And then const cred key. So we're going to use a constant for our key, call it creds, using our new type. And then we'll have a set credential function that calls context.withValue using our package save key, and then some encoded credential. Again, this is just a pretend like credential object, and then a get credential where you pass it a context and it will return the credential if it exists. And we'll do some of the same parsing and credential validation that we saw on the last slide. Return that if valid, otherwise we would return nil. And the power of these common packages is this package can be imported by both clients and servers. The key is type safe, package, private key. You don't really make mistakes copying and pasting around key objects. And the set credentials can be called by clients to attach their credentials, and the get credentials can be called by servers wishing to read out those credentials. And the clients and servers don't really have to care about the implementation or how they're baked into the context object. They just know that it'll work, essentially. They can pass their thing and they know they can retrieve it later. So the last thing I want to talk about is the done function, where we watch and we wait to see if we're canceled, and then we can do work otherwise. So in this case, a common pattern is to have some sub requests like process request at the bottom there, and our main request will listen for the done function and then spin off the sub request. So the first thing we do maybe is create a channel that signifies whether our sub request was done. So we make a work done channel, and then we spin off our sub request called process request and output its error to the work done channel, which could be nil. And then we use those fancy Golang select statements where you can pull from two channels in parallel, and we'll pull from both our own work done channel, or we'll pull from context.done. And so what's happening here is we're doing two things in parallel. We're doing the work of this RPC in a new Go routine, but we're also listening and waiting for this context to be canceled. So if context.done, if it times out, or if we're marked as canceled from some parent before we finish our work, then we can return early. There's more fancy stuff you can do to like free up resources, but we at least return early and we stop spinning off sub requests. And then there's a lot of packages built around this type of functionality. There's extra sync error group, which is useful. Basically does the same thing, but a lot cleaner. So you create an error group and it has functionality to just pass it the context, like parent context that we care about. The error group will automatically listen to the done function. And then we can spin off Go routines calling, error group g.go, and then our sub request, and we could call g.go a bunch of times. And then there's a blocking g.wait that will wait for either the done function to finish and give us that error, or one of our sub requests to error out, or just return nil. So yeah, if you were to pull the context talk.done channel, you would see that it's now closed, and you can print line questions. So there you go. Hopefully, I don't know how long I went. I know it's kind of a long talk. I talked as fast as I could, but the voice is getting hoarse. I got to drink.